Breadboard Simulator is an awesome application because, unlike other simulators like Multisim or LTSpice, it helps us visualize the positioning of physical electronic components when placed on a breadboard. In real life, when you connect electronic components using wires, it actually becomes messy when you increase the number of components and number of connections. And this reality is depicted by Breadboard Simulator. I think it's an excellent idea to make a simulator a desktop application instead of a web-based application because not all students have access to the internet 24 hours a day, 7 days a week. When you examine the interface of Breadboard Simulator, it has a neat and friendly look. You're not overwhelmed with tons of visuals like what you see in other simulation softwares. Let's try to explore what these buttons and other options mean. Let's begin with the menu bar containing File, Edit, Circuit, and Help options. When you click File, it gives you the usual application options like New, Open, and then we can open some sample circuits and tinker it to build new configurations. Then we also have Save, Save As. So let's explore the Breadboard Simulator menu bar. The menu bar usually provides the user with a quick access of a program's essential functions. You select File, New, if you want to start from scratch. Sometimes, when you're building a simple circuit, it's easier to construct it starting from a clean breadboard, then place the necessary components, then connect it with wires. Or if you already have a sophisticated circuit that is not working, and you cannot debug it or cannot find the problem, well, you can just click File, New, then just start over again. Sometimes it's easier that way, especially when you already spent so many hours debugging your circuit. File, Open. File Open allows you to open existing circuits previously constructed using breadboard simulation. Let's try to open. Notice that when a circuit is created using breadboard simulator, you can save such circuit and it will have an extension of .bbrd or .breadboard. So for example, I want to open this sample underscore RC circuit.bbrd. I'll just click it and then its file name will appear in this file name field and then I'll click open and then I'll be able to open this previously created simple series RC circuit. File, Sample Circuits. You click File, Sample Circuits if you want to open existing circuits that make use of common electronic components. Here we have 555 timer circuits. In astable mode, the 555 timer can deliver square waves oscillations. In bistable mode, the 555 timer can be in either of two modes, namely output high or output low modes. Hence, in this state, it can act as a flip-flop. In monostable mode, when a particular time interval is reached, the output pulse stops. The circuit keeps quiet until another trigger pulse is detected. Next, we also have basic capacitor, diode, and LED circuits. And we can also load 4511 display decoder, counter circuits, digital ramp, analog to digital converter, light chaser circuit, I don't know its function, and a bunch of multiple digit counters. We also have a bunch of logic gate circuits, flip-flop circuits, and a shift register circuit. We can also load comparator, constant current source, and window comparator op-amp circuits. We also have this MOSFET, NPN, and PNP transistor circuits. So the advantage of using these template circuits is that you already have a configuration that you can tinker in order to set up the circuit that you want. For example, let's load an astable 555 timer circuit. Notice that it has two oscilloscope probes so that when we run this circuit, it will display the voltage signal from these nodes. 555 timer has 8 pins. If I try to draw this 555 timer, so pin 1 is the ground pin. Pin 2 is the trigger pin. Pin 3 is the output pin, while pin 4 is the reset pin. Pin 5 is for control voltage. Pin 6 is for threshold. Pin 7 is for discharge. And pin 8 is for the power supply. So notice that pin 3 is the output pin of 555. So returning to our circuit in the breadboard simulator, there is a connected probe, oscilloscope probe, so we can monitor the voltage output of this 555 timer. And this output is also connected in series with an LED. Every time the 555 timer releases a voltage high output, this LED should light up or blink. So if I try to click run, this will open up the graph view window and it will display the voltage signal that is being detected by these two oscilloscope probe. Every time the output of the 555 timer is voltage high, the LED is turned on, as depicted by this plot. Let me stop this and let me delete this blue oscilloscope probe. I'll click this delete button and then run the simulation again. Notice that there's only one plot here and it is the red oscilloscope probe. Since this 555 timer circuit is already available in the sample circuits of this breadboard simulator, I could just edit its features or its properties so that I can use it in my future circuits that require some timer. So for example, I could just simply connect a new circuit from the pin 3 of this 555 timer because it's the output pin. And I can also modify the properties of this timer without building it from scratch. So for example, based on this graph, let me run it again. It seems that the duration of the voltage high output of the 555 timer is 1 second. Now if I try to edit this capacitor, I'll just right click it and then properties. So what if I try to double its value? For example, 47 times 2 is 94. Click OK. And let me run it again. So apparently, this initial voltage high output has something to do with the capacitor interacting with the 555 timer, but apparently the succeeding voltage high output is now consistent with each other. And let me pause it. So notice that the duration of the new voltage high output is 2 seconds because I edited the value of the capacitor and I doubled it. This change was reflected in the output of the 555 timer. So I could just tinker this or change the properties of this already given setup or this available setup and just use it in my future circuits. So that's the advantage of using these sample circuits. File, save. If it's your first time to save the circuit, obviously you have to click save and then type in the name of your circuit. So when you click save, your circuit will have an extension of .bbrd. File, save as. So you usually choose save as when you want to save minor changes to your circuit and at the same time retain the previous circuit. So for example, I want to preserve this circuit, so I'll just click save. Let's say I'll save this as circuit 01. Then click save. Now this time, I'll change the properties of this output resistor and perhaps change it to 1000 ohms. Now this time, I don't want to change circuit 01, so I'll click file, save as, then I'll save this as circuit 02. So obviously, I'll now have two copies of the same circuit, but with some minor changes. Circuit 2 has a doubled value of output resistance compared to circuit 01. Next menu bar option is edit. When you click edit, there's this usual options like undo. By the way, this undo button has quick access button here symbolized by this return arrow. You usually choose undo when you want to undo or revert some changes. Next is redo. So to demonstrate this, I'll just put some resistor here and then diode. I'll connect it to power supply and then to ground. So for example, I'll just put some wires here randomly. So if I click undo, it will revert back to my previous changes. Okay. Next, if you click edit redo, by the way, this redo also has a quick access button here, symbolized by this forward arrow. So if I click redo, it will bring back this wire that I previously undo, something like that. Next is edit selects. So it also has a quick access button here in this toolbar, and it's represented by this arrow. So you click this arrow or select button if you want to select a component and then drag it. It seems that wires cannot be dragged. So the best way to reposition a wire is to click delete, this X button here, and then just click this place wire and then just reposition it from the start. So click the starting point of the wire, for example in this hole, and then end point. So click it again. So by the way, you can only draw the wires vertically or horizontally. It cannot be placed diagonally along this breadboard. So next is edit interact. It also has a quick access button in this toolbar, and it is represented by this screwdriver. We usually use interact if we want to see the current value of, for example, of this resistor. It will display the voltage and the current that is currently detected in this node. You can also place this interact button on wire. You can actually see the voltage in this wire. This black wire here has 0 volts because it's directly connected to the ground. And by the way, when two wires are connected to each other, they share the same color. If you use some input devices, for example, 10K potentiometer, and then I'll just click the hole where I want to place the upper leftmost corner of the component. I'll click interact, and then I can now rotate the knob of this potentiometer. And the same goes for a push button. I can only push this switch if I will enable the interact button. Next is edit place component. So it also has a quick access button in this toolbar, and it is represented by this resistor symbol. So if I click this, I can now select any components here. For example, I'll click this 1 ohm resistor, and then I just click on one of the holes of this breadboard to position the first pin of the resistor and then the second pin somewhere. So I'll click it again so I can drag this to lengthen the connection of this resistor. And by the way, you don't really need to specifically choose a particular value of resistor or capacitor, because you could just right click this. For example, I'll enable the select button and then right click on this component and then click properties. So I can just modify their value using the select button, then right click. Edit place wires. So it also has a quick access button here, and it's represented by this pencil symbol. So if I click this, I can now connect the electronic components to different holes or different power supply or ground or other components. Next is edit delete. So this delete option also has a quick access button in this toolbar. It is represented by this X mark. So if I click this, I can now begin deleting wires and components. For example, I can delete this one or this resistor, these switches, this potentiometer, etc. Next in the menu bar option is circuit. It contains the run button, which has a quick access button here, symbolized by this black play button. When you click this run button, it will run the simulation. So let me have a better demonstration. I'll just open another sample circuit like the A-stable 555 timer. So when I click this run button, it will run the simulation. So if you have LEDs like this one, notice that the LED is turned on or it blinks. And if you have oscilloscope probes here, this run simulation button will automatically open the graph view window and then display the voltage versus time signals that are being read by these oscilloscope probes. Of course, we have this circuit stop, or this stop button also has a quick access button in this toolbar, and it is represented by this black square. Apparently, when you click this, it will stop the simulation. Let's see what will happen if I try to delete this oscilloscope probes and then run the simulation. Notice that it didn't open the graph view window because we don't have an oscilloscope probe on the breadboard. Next is the circuit settings. So if I click this one, it will open the circuit settings window. I'll just discuss this on the next video. We also have this circuit show hide graph, which also has a quick access button symbolized by this triangular and square wave graph button. If you click it, it will toggle the presence of the graph view window. Meaning to say, if the graph view window is open, it will hide it. So if I click this, it will hide it. Or if the graph view is hidden, by clicking this show hide graph button, apparently it will show the graph view window. In other words, when I click this button, it will toggle the display of the graph view window regardless of whether the simulation is running or not. Finally, we have this help option that contains contents. Let's click it. Apparently, if it's your first time to use Breadboard Simulator, then I suggest that you quickly browse all of this. Also, we have this help getting started, but this is just a shortcut option because this is contained in the contents HTML file. And it has an important guide like how to place components, how to place wires, how to probe voltage signals using oscilloscope probes. Breadboard Simulator doesn't have multimeters because oscilloscopes can act as voltmeter. It just displays the voltage as a single DC signal if you try to use this as multimeter. And when you want current, then you can just use Ohm's law from that voltage DC signal, or use the interact button and hover it to a specific wire or electronic component to show the value of the voltage or current detected on that component. This getting started guide also explains how to run the simulation. Going back to the help option, click help. Then we have this about feature. So just like most applications, this software also has an about feature that usually tells us the version number of the software and some other details. At the time of this recording, I have this version, and thanks to this guy, David Shah, we have this awesome software. It also has this other infos about the licenses and how to report bugs or errors about the circuit. So if you encounter any errors about Breadboard Simulator, you may email this guy. Click OK. Don't forget to like this video, subscribe to my YouTube channel, and hit the notification bell button for awesome updates. Thank you for watching.